Good morning, everyone. My name's Paul Coddington. I'm one of the Deputy Directors of the Nectar program, responsible for the Nectar Research Cloud. So this morning we're going to have a session with 3 short talks to talk about the use of Openstack as research infrastructure. So I'll kick off. So I'm going to talk a little bit about the Nectar Project. So that's funded by the Australian Government as National Research Infrastructure Funding. The project started in 2010. We had our first OpenStack cloud up and running in early 2012. So there's basically 2 things that the Nectar project does. So we provide cloud-based infrastructure for research collaboration, and the point here was this is funding, this program was funding collaborative research infrastructure, so it's meant to be to support research collaboration across institutions and internationally. And we want to be able to enable the research community to store and access and analyse data. So there are 2 parts of that. We have the research cloud, as I said, the OpenStack cloud, which provides a compute infrastructure. And we've specifically designed that to have a self-service capability. And then the other part is what we call the virtual laboratories program. So that relates more to the applications that are running on the cloud to make it easier for researchers to use the infrastructure to do what they want to do. So the next talk will cover more about that. I'm just going to focus on the research cloud. So first of all, why would we want a research cloud? So in the research space, as in everywhere pretty much, there's large and growing volumes of data being generated that need to be stored, managed and processed and analysed. So, this is typically more capability than people can do on their desktop computer, so they need more powerful computing capability. But, and in the past, the only other option really was a sort of traditional high-performance computing or cluster computing type environment, but that's not particularly flexible in many cases. So people wanted more flexibility. They might need environments to run their software that isn't supported by their local IT, who could potentially provide them with a virtualization or virtualized virtual machine, a virtualization cluster. But there are often restrictions on that. It's often managed in a more sort of enterprise-style environment, and HPC is a particular way of using things that is a bit inflexible. You have a particular operating environment and a particular operating system often, and you submit your jobs in a batch fashion. That's more difficult to do things interactively. So we wanted to make a more flexible, easier to use environment for researchers. They need to be able to collaborate across institutional boundaries, so we don't necessarily just want a VM inside your institution that your local IT sets up, and then it's difficult for your collaborators at other institutions overseas to access that and share that infrastructure. So that often means, because of this lack of sort of flexibility and lack of providing what researchers need, they often buy their own kit and just manage it themselves, right? So we'd prefer not that, or I'm sure they would prefer not to have to do that. We could do that for them, but make it just as easy and flexible as if they were operating it themselves and they could essentially do what they want. So they want to be able to do what they want when they want. So we're looking at a self-service solution. Infrastructure as a service, on demand. I can fire up a VM, I can manage that VM, I can do what I want with that VM. And this is a sort of innovation culture, both for the researchers, the users, obviously, but also for our providers. It's more of a sort of, for the developers, for the operators of the system. In a research environment, they're more used to having a bit more sort of freedom and to do innovative things, I guess. And at the end of the day, we want to increase research productivity, so people can easily do what they want, either however they want to do it, or we provide the tools to make it easier for them to use so they don't have to do everything themselves. So we decided on OpenStack. So I think when that decision was originally made was back in 2011. So OpenStack was in very early days, but there were a number of other potentially competing options. So it was ended up being a very good decision. I think if you made that decision today, it's a much easier thing to decide than what it was back then. So fortunately, we went with OpenStack. So it's very cost effective. We can run things at large scale. It's perhaps more cost effective than using a public cloud, and it's scalable. You can just add more resource to it as you need or as you have the funding. In a research environment, bang for the buck is very important. You have limited funds for IT. People would rather spend their money on people, on researchers for their groups rather than paying for IT. The locality is important. So again, one of the issues with using a public cloud is in many cases you have instruments that are generating large amounts of data, or you have existing data sets that are sitting there on infrastructure within campuses or within some of the IT providers that we already have, and you want to have locality so you can analyse that quickly. Now, in the research space, you don't really need 24/7 support and 5 nines uptime like you do offer in public clouds. If a VM goes down or a whole cell goes down, no one's going to die. We're not going to lose millions of dollars worth of revenue. So if there's a bit of a trade-off between give me more resources, between give me resources that are up 5 nines, there's often give me more resource. That's more important to me. We don't need commodity off-the-shelf enterprise-grade solutions. In fact, in the research space, new innovative solutions are often perceived as being better. And we have to deal with the tension between collaboration and competition. So in the research space, collaborations is a good thing. You want to collaborate with your colleagues, but to some extent you're also competing with trying to do better than other researchers, so you can make your discovery first and so on. So you want to have a system that is sort of standardised, or a de facto standard. It's well supported, lots of people use it, but you can tweak it, you can change it, you can customise it to do new and different things. So open source solutions that are used by lots of people internationally, have a big user groups and support groups are a good thing. So AAF is good. I should say one of the customisations we did do in ours is to support our federated SAML identity provider at the universities in Australia, called the Australian Access Federation, or AAF. That's been a big win for us because people can just log in using their university credentials. They don't really even need to get an account. They can just log in and away they go, start using the cloud. So that's really driven uptake. So, as I said, back in 2012, we were essentially, I believe, the world's first federated research cloud across 8 institutions across the country. Now, it was only 8 institutions, but essentially that encompassed all of the research institutions in Australia, because these nodes, as we call them, the research providers, were each supporting their local institutions or universities or medical research institutes or whatever. So essentially this covered pretty much all of the research organisations in Australia. Now, since then, one of the nodes, the Pawsey Centre in WA, has moved out of the Nectar Cloud, and it's running its own OpenStack infrastructure, so it can more tightly integrate with its high-performance computing environment. It's one of our 2 national supercomputer centres in Australia, but we've had a couple of other institutions join as well. So it's been wildly successful. We've had essentially, these figures are up till sort of towards the end of last year, pretty much linear growth in the number of users, 40% a year, and pretty much linear growth in capacity to match it as we brought new nodes on gradually. They didn't all start at the same time. They each added capacity over time. It's pretty much plateaued in terms of capacity from the end of last year, but the number of users keep going up, so that's an interesting problem. And off on the right there, you can see this is a chart of all the different research areas that we support. So most of the usage comes from the biological sciences, genomics and so on, IT, computer science, but there's across all disciplines, all sciences, engineering, even humanities, arts and social sciences are usage as well. So we have a federation. One of the things that I guess makes it different to some of the clouds is we're a federation across multiple organisations at multiple sites. We do that using OpenStack cells, and we were one of the earliest groups to use and push OpenStack cells. Users can ask for their local site if they want to. Maybe their data set's local and stored at that site, so they might want to run their VM there, or else they can just say, don't care, run it anywhere, and I'll schedule or go off and do that. We have a group that runs the national services, and then the federated services which are run at each node of the cloud. We're also deploying a number of the higher level services across the cloud as well. Trove just came on board recently, Heat and Murano, Neutron and so on. Manila, we've got a couple of nodes doing that now, and we're rolling that out. So it's basically a mix of federally funded resources, locally funded resources that get added to the cloud. It's a standardised cloud, but the local nodes can add their own customisations on top of that if they want to. They can have their own specialised instances if they want to. And one of the important things we do is we provide standardised golden images. Here's your standard Unix platform, but also community contributed images that might be particular software, particular suites of software, and those are very important as well. So we have a group that manages the central services. We have a group of all the node operators that run their own local cloud, and we get together and periodically and talk about how we do that. And we have a distributed help desk that a lot of the local help is provided by the cloud nodes to their local users. So we like to think of ourselves as pioneers of this research cloud, but of course there's a large number of these now. Openstack clouds, as you saw with ours, the uptake has been huge. There's a big demand for this kind of thing. So there's now very large numbers of clouds around the world. We want to pursue sort of interoperability between these clouds. So for international collaborations, for example, people can run jobs on Nectar. They can also run jobs on some other cloud that they've got access to overseas. So we're looking to make it easy for researchers to collaborate and share infrastructure with their international collaborators, to reuse applications and workflows that might be developed elsewhere and should be able to just run seamlessly on our infrastructure. We'd like to be able to make use of public cloud if they wish to have additional resources and are willing to pay for it. And we have involvement of a number of international groups that are working on developing interoperable solutions and tools for research clouds around the country. And one of the things we've been doing recently is working with institutions in New Zealand to develop work towards development of a New Zealand research cloud that is federated and interoperable with the Australian cloud. So that's it for my section. We'll have a couple quick questions if anyone has, and has any, and then we'll go on to the next presentation. Any questions about the Nectar Research Cloud? Nope? Okay, we'll go on to the next session, the next talk then. Thank you.
Thank you. Thanks. Thank you, Paul. And I'm Glenn Maloney. I'm the Nectar Director. So I've been around with Nectar since the very early days, back in 2011. It was actually April Fool's Day 2011 that we chose Openstack, which was an interesting sort of omen, but it worked out very, very well for us. It was a challenging time because there was a lot of, we got a lot of communication for a lot of people across the IT sectors in the universities in Australia who really felt that we'd made the wrong choices with Openstack. There was a lot of FUD occurring in the space, but it has worked out extremely well for us, and we're very pleased with the value we've gotten from the Openstack Foundation and the Openstack software community as well, and being a part of that community. But what I want to talk about now is some of the work we've done that Paul talked about before in the virtual laboratory space. What have we done to engage and support research communities to leverage the research cloud? So the Nectar Research Cloud service, as it is, operates an infrastructure as a service offering. One of the challenges is if you want to go towards software as a service and other things, I'll come to that, you've really got to go work up a really differentiated stack in each domain. Each research domain has highly specialised software, highly specialised methodologies and algorithms that they use within that space. And if you want to walk up the service chain, you've really got to engage with that differentiated need in the different research domains. So looking at that in the research world, it is true that software is eating the research world too. And in research, there's an enormous amount in each of the research disciplines, there's an enormous amount of effort being sustained by those communities and in many cases by their commercial partners to develop the tools that research needs to do research, the data analysis tools, whether it's tools to software packages to actually analyse data coming off remote sensing instruments for monitoring the environment or studying species distributions and so forth, or if it's trying to do actually support and develop the climate models that inform our climate prediction systems and so forth. So really what we're doing in research is we're encoding our understanding of the natural world into software. So software becomes a really important strategic part of what we do. Astronomers code what they know about cosmological models into software. And it's the software that's the repository in the digital world of what we know about the human and the natural world. And also the actual ability for us to actually process the observations that are occurring. There's a larger and larger data deluge occurring in research. Research for a long, long time has been dealing with enormous volumes of data. Typically, research did that using patterns that were established in the research spaces. My background's in particle physics. We developed a whole methodology for dealing with the huge volumes of data over time. But increasingly, there's much we can learn from industry as well in that space, and we see the opportunity to actually see some of sort of leverage some of the approaches that have been emerging out of industrial approaches to large data in the commercial sector. But one of the things that's really important is the need for ongoing rapid refinement and innovation. Research at the bleeding edge, it's about new knowledge. You can only do so much by just reusing an existing software service for a certain period of time. You have to be pushing the boundaries, to be exploring and uncovering new knowledge. So there is a need to actually have to support a very active and dynamic, evolving software landscape. In each research discipline, there are always new versions of tools with new algorithms, with new approaches being adopted, and we need to be able to support that kind of rich development that occurs. So one of the things Nectar did, we funded a virtual laboratory program. And what we recognised was that, it's not software houses who are going to develop all this software. Most of that software occurs from research communities themselves. There are whole global communities working on software in climate research. There's whole global communities working on software for bioinformatics and genomics data analysis and so forth. But what we sought to do was create partnerships with service providers in the sector to actually be able to create platforms to make that software available and more sustainable and higher quality in the sector. So what we did was funded consortia in these spaces. So each one of those projects that's listed up there tries to address some need within a research domain. It's highly collaborative. They typically have 6 to 20 universities participating in the project, and they're all focused on taking an infrastructure approach to software. And that's one of the things that we've sought to do in that space. Now, and while that's happened, we've also sought to leverage the investment in the research cloud to do this as well. When we started our virtual laboratory program, I'd have to say there was not much awareness of cloud in the research sector in Australia. So as they evolved, they gained a much deeper understanding of what the opportunity they had to actually leverage the Openstack cloud that we have in Australia to actually be able to dynamically and provision compute and storage resources to meet their needs. A bit of a case study, one of the things that's occurring in these virtual laboratories is a bit of a transition from the model of where research communities and groups that Paul talked about would have their own infrastructure and they're responsible for their own software and so forth. And each group in each university would have their own copies and manage their own software stacks in each area. To actually here, the whole community in that sector can just support a software stack that's running in the cloud that we have in that space. So that's what these platforms are. So Genomics Virtual Laboratory gives people an opportunity to actually just go and access genomics tools, a rich suite of genomics tools to do their analysis available to them on the cloud rather than having to host and support that on their own infrastructure. And one of the things that emerged out of these virtual laboratories was the value of the integrating component, the ability to put an online environment out there to have access to the data from that online environment and actually to enable people to rapidly access the data they need, to access the managed and curated tools and models and software that they required. And typically what we'd see from these groups is stories of just how much that's accelerated research. People saying, you know, essentially things that took them the first 6 months of their PhD was typically provisioned and ready for them to run as a starting point. So there was a strong acceleration factor that occurred there. So really what's transitioning is there's now this view that we just go to access the kind of data analytics and modelling we need as a service that's occurring in this space. But it was important to do that by domain and to partner with those domains as sort of like IT service providers and advanced e-research service providers in our sector. We can't have the expertise to run the climate models for them, to run the data analytics software, but we can work in a partnership with them to support those complex software environments. Did that go once or twice? There we go. So what we're seeing is really there's a transition to this research software as a service that we're trying to do. So, and it's recognising you have to do it in partnership with the domains because of the depth of expertise that's required for the advanced bioinformatics algorithms that exist only within the bioinformatics community, for example. So we have to create that partnership that's there. One of the questions when you move to research software as a service compared to the kind of prior practice that happened there is, how do you sustain and support that? So previously the model is certain groups and collaborations would develop software, but each group around the world or around Australia would have to manage that software themselves in their own environment. If you're moving to a model where that software is available for you as a platform, you need an operating budget and a support budget for that software. So one of the transitions we have in the sector is how do we move to that culture of service provision in that space. And increasingly what we'll be seeing is that software is the infrastructure, it's the strategic infrastructure, the hardware is the consumable. And it's got to change from the thinking that was around the place around 5 years ago, where it was questioned whether software could be thought of as infrastructure at all, and the infrastructure that mattered was the hardware. So one of the things in that environment, one of the things at a later phase for Nectar, just a few years ago, we started to think to ourselves, well, we've built this cloud, we've funded the emergence of some platforms to meet some needs in those sectors in the virtual laboratories. And we built the cloud and we said to people, you're welcome to come and use it. You know, come and use it. And we had the national research priorities and the research disciplines and domains come and start to use our Nectar cloud. But what we're aware of is each of those disciplines, research disciplines, has a national decadal plan for their strategy into the future of what their priorities are. So how do they plan to rely on us as a provider to support them? So one of the things we realised was what we wanted to do was transition to a model where we created that sense of ownership and partnership at a broader and larger scale level across the needs of the entire domain. So we proposed a model where the Nectar Cloud represents that infrastructure as a service component at the bottom. And essentially what we look to do is that there's a front door for each of the discipline domains. So instead of thinking the research cloud as being the Nectar Research Cloud, what we want is a portfolio of clouds in each of the research disciplines with a strong sense of ownership and partnership with each of the national priorities in each of those research disciplines. So we got a lot of engagement with this model. There was a lot of interest and support in the approach. We started by working with 3 research disciplines to do some pilot work in this space, and we had quite some success with that approach. The intention here is that we see that there's much more reason for research organisations and universities and researchers to invest through this front door into the cloud that we're getting in this space. So what we want to do is create a research cloud infrastructure that underpins and supports the strategic priorities of the Australian marine science community, and similarly for the Australian ecosystem science and the biosciences cloud. We've had we're on steps in that direction, but the model's actually getting a lot of support, and importantly, we're getting a lot of interest in the approach across other research disciplines as well. So what's emerged? They've really become a vehicle for much more enhanced and strategic collaboration with the research priorities in that space. So there are national research priority investments in each of those research discipline areas, and this leads us to a much deeper partnership with them around how we can deliver infrastructure to support their needs over time, in data and in software. It's a framework for collaborating on research software as a service, so moving further up that stack in a more strategic way. And one of the important things we've learnt is really to think of it as a socio-technical challenge as well. It's not just about designing the platforms, it's having to put the social framework in place and the governance models and so forth for these groups to feel that ownership and to feel that they've got that direction and ability to direct and set priorities for the infrastructure as we move forward. And one of the things that we asked is this was a pilot, would this be of interest to other research domains? Is this a model that could be a useful vehicle for carrying forward important strategic investments? And we've got a lot of substantial interest, everything from the astronomy to the humanities talking to us about this model and the opportunity to actually do something in this space. So that's finishing up the science clouds. I do want to say one of the things that's important changes that's coming in terms of the national landscape in Australia is that Nectar is now joining with two of our joint investments in our area, in related areas in e-research, and that's the Australian National Data Service and the Research Data Service. They're two separate programs, and we're going to create, the intention is to create an integrated Australian Research Data Cloud. Now that transition is not funded yet. It's been essentially indicated in a roadmap for future government investment in this space to get a much more integrated kind of capability that occurs around this that builds on the cloud and the other investments we have. So what will happen in that future is that there will be something called an Australian Research Data Cloud. The Nectar name will go away, and this will be a sort of a more coherent investment that occurs out. And one of the important priorities in that space is going to be really deep collaboration and integration with international activities in this space as well. It's going to be a big priority for the ARDC. So thank you. So, and now we've got Steve is going to talk about an institutional perspective. So Steve Quinnett, who was at the keynote, helped participate in the keynote yesterday, is going to talk about from Monash University and look at sort of a university perspective on the value proposition of these kinds of investments as we move forward. Thanks, Steve.
All right, so that's on, isn't it? Yep. Thank you very much. So Glenn and Paul asked me to provide that institutional view. So in Glenn's prior slide, we saw a mandate or an intent to differentiate a common infrastructure or ability to have a common infrastructure across the nation, that infrastructure layer, as differentiated from research domains. You know, a sort of bioscientists want to do something particular. The same idea carries through to institutions in Australia. We have in the order of 30 kind of universities, but there's a few which are much bigger than the rest, and we have this ability then to look at research disciplines in the broad and trying to support the whole lot. What I have up here on the screen is a diagram which I've been showing for a little while, and I want to just first focus on the middle box. Now I realise the text is going to be hard to see, but what this is on the x-axis is essentially the amount of time someone uses a CPU, right? And on the right axis is like a utilisation measure. And what we did after 2 years of the Research Cloud in action, we went and surveyed the many hundreds of users and their usage of the Research Cloud, and we were able to categorise their usage into different boxes in these axes. And the real important ones is to recognise that the top left-hand corner, it says HPC. I'm not sure if that's actually quite readable. The middle green one is interactive. There's continuous light use, and there's managed services and things like that. And why that's important is if we look at the way that the public cloud and even OpenStack asks us how to ask for a resource, it says, well, you tell us what flavour you like. But that kind of does it make our life easy? How do we know if a person is replacing the desktop, the workstation on their desktop, and they want 100% of the CPU? How do we differentiate them from someone who is running a web service? We don't know the answer if we just ask which flavor necessarily. And so we were able to create this map and then rethink about how we give allocations away or resources away. That enables us to do something that's really, really important and the most important part, which is if we look at the institution at large, our role becomes to aggregate the resource use, and we need to know more information about it. So what this diagram says is at the bottom, we want some infrastructure where people can have, they can be different what we call tenancies, different funds or payees or whatever else, and they prioritize access to the resource. And we want the resources then to be the right shape for researchers and leading researchers and long tail or following researchers who just want things easy to be able to play in that environment. And at the top, the virtual labs and the various environments are the things that we then need to spend our time to help our researchers to create these platforms for their domains. So obviously Nectar as a self-service thing is one access mechanism. That's someone who really does want to use it like a public cloud, if you like. I go and get a VM for myself, I do something. M3 is our code name for our high-performance computing infrastructure that's specialized in image processing. And there we're immensely motivated to get traditional HPC-style performance working with not IPC messaging, so I'm not really interested in MPI necessarily, although it's, that's important. It's really around the performance of data into the processing engines themselves. And there we want GPUs and things like that, where our primary interest is around deconvolution and deep learning. Monarch is our Monash University HPC cluster, if you like, for the masses, right? And it's much simpler, and it looks different. But the stack is the same, and the infrastructure it uses essentially is the same. Whereas the characterization virtual lab is one of the domains that Glenn just talked about, and really asked in the question, how does this fabric permeate across the whole nation to places where there are instruments somewhere else? So that's what the research cloud means to us. It's not something like an Amazon. It's a way of looking at the world that allows us to think about the aggregation of resource and specialization. Now this graph is real Monash data, and I'm not going to explain to you how I made the numbers, but it's a proxy for understanding the amount of compute that we need, and it's fascinating. It says, since 2013, that the actual utilization or demand utilization has grown at 85% per year, compounded growth rate. And what's really interesting about this particular view of it is that we get to see the effect of new infrastructure coming about. We can see there's 330%. That's 3 times, 3 times in the year. It's tripled over the year through times. And there's another one at 130. And these phenomena occur when we make new resources available, right? And then it flatlines a little bit because, well, the resource is full. If we, unlike storage in some ways, when we give researchers the availability of capacity, they're just going to drink it up, right? There's no cost to them. I've got another graph around storage, which is at 75% compounded growth rate, but it's consistent at that growth rate across all domains, as in that's the aggregate of all domains. The interesting, what I also like about this graph is we made a mistake on the architecture of our first research cloud deployment into the research cloud, and we had to turn it off, and that's what that dip is for a little bit, was it, and essentially reprogram our networking at the very most bottom level. What's also interesting is in December to February period 2017, which is not on this graph, we had to change data center. And because we're taking this OpenStack approach, we were able to put some portion of our research cloud in the new data center and essentially move a rack at a time across to the new data center, and had no downtime for any of our researchers on that infrastructure, which is phenomenal, right? We moved an entire research data center that way. Of course, the HPC parts had to be turned off because queues don't work that way. HPC it doesn't work that way, but everything else did, and that's amazing. This graph alone is the thing that scares us as an institution. Computing infrastructure, or out there is sort of growing at maybe Moore's law-ish, which is 50% compounded growth rate, which means if we want to continue to feed this demand, we have to think about how do we make the aggregation of resource better and make it researchers utilize the resource better, because we've got a essentially 30 to 40% margin that is a cash expenditure increase every year unless we do something. So thinking about the software as the infrastructure, or the software as a place where we're focusing the effort, that becomes really, really important when you consider that's the only place where we can get researchers to take domain knowledge and inject it into the infrastructure to make things efficient. The last slide I'll put up is, and I took the dollars out just to be kind of nice about that, just to not give away too much trade secrets, I guess. But on the vertical axis is time, and what I want to show here is when we started off, there was the Nectar investment itself. It's in the yellow, and there's proportional size of investments essentially in the size of them here, Nectar asked us effectively as an institution to put this research infrastructure outside of the, let's call it the CIO's firewall, the enterprise's firewall, and to make the research resource itself accessible. Now, to begin with, it was just using the Nectar dashboard, but then people wanted to be able to prioritize access beyond what was available for merit allocation and everything else. And we saw that people would invest in expanding that accessible infrastructure to be able to prioritize those resources for themselves. And so the blue colors are where Monash University itself has made an investment directly for Monash researchers. And what's sort of interesting is that to feed that engine of that aggregated growth rate, our focus has been to prioritize access for ourselves rather than necessarily waiting for the national government and everything else to try and work out how we make communities have resources for themselves. And so what I find interesting about this particular graph is we took the innovation that was a national project, and we worked out how to use it and bring our own money into it and not have to think about building a new computer that's a HPC that's separate. We've actually saved a lot of money, a lot of effort, a lot of expertise by joining the two together. I think that's really all I want to say, actually, in terms of the Nectar Project and the Research Cloud. I think the core message from the institution is we want to work on national things and making our researchers be much more connected to everyone else and the rest of the world. And we also need to think about how do we provide resources to our researchers in a way that they are outstripping the largest innovation space in itself. There's not many things that grow beyond Moore's law, and yet the demand coming from the research fraternity is outstripping it. So we need a model, which Glenn was alluding to, that enables us to co-invest in a way that allows all of us to leverage the knowledge that's inside our researchers' heads. Thank you.
Thanks, Steve. Now we've all pretty close to time now, I think. So I want to thank you all. One of the things I'd like people to take away from if the university and research sector is Nectar's really interested, and all of the stakeholders are really interested in ensuring what we do maximises the opportunity for synergies with what's happening around the rest of the world. So we're really interested. There is a question up there. Yes. Actually, it's an observation and an invitation.
At
Yep.
1:50 in C4.10.
Okay.
So I'd like to invite everyone to attend.
Excellent. Thank you. Thanks for that observation. And, you know, we'd like to have that interoperating large, some kind of loose federation of these global research infrastructures, because research is collaborative and global in nature, and our infrastructures need to be as well. So thank you very much.